Yeah. Good evening, everybody. And we'll solve some questions which were given to you in your daily quiz for engineering mathematics course. And this is the second quiz of fourth week of April 25. Okay. There are only 3 questions. Usually there are like 4 questions in each quiz, but no issue. We'll solve them. Okay. So let's get started. So the first question is, if the characteristic roots of a 2 by 2 matrix, which is given as 3, 7, 2, 5, are lambda 1 and lambda 2. The characteristic roots of another 2 by 2 matrix are what? That is the question. And first of all, you should know characteristic roots are nothing but eigenvalues. Okay, so this is a synonym for commonly used term eigenvalue, but sometimes to confuse students, they use these kind of terminologies. So those who have not prepared these things properly, they will get confused and either waste their time or lose their marks. Okay. So now they have given you a 2 by 2 matrix and lambda 1 and lambda 2 are eigenvalue of that. So the conventional way is to find the eigenvalues of this matrix. Let's call it as matrix A. Okay. The conventional way tells you to find the eigenvalues, okay, either directly by solving the characteristic polynomial, or in some questions you can take the help of properties of eigenvalues, which is nothing but, the sum of eigenvalues is the trace of the matrix, and the product of eigenvalues is nothing but determinant of the given matrix. Okay, so you can do it that way also. There are 2 ways to do. First is the conventional characteristic polynomial solution. So you'll have quadratic polynomial in lambda. So the 2 solutions will be lambda 1 and lambda 2. Another way is using properties. Sum of lambdas is equal to trace and product is equal to determinant. And from there also you can get lambda 1 and lambda 2. Okay. Since this is a 2 by 2 matrix, that also works. The second method doesn't work in 3 by 3 matrix. Okay. Usually in 3 by 3 matrix, if all the eigenvalues are unknown, you are supposed to solve it using conventional method where you solve for characteristic polynomial roots, okay, or characteristic equation roots. But here, if you look at the options, they are only talking about in terms of lambda and lambda 1 and lambda 2. So you should get some hint from this only, because if you look at this matrix A, let's go to the next slide. This matrix A is 3, 7, 2, 5. Okay, so sometimes directly solving the question is not a good idea. You should spend some time and think about it. So if you look at it, the determinant of this matrix turns out to be 15 minus 14. Okay, that is 1. Okay, and what is the A inverse in this case? So you should know the trick for finding the A inverse. So first of all, you should multiply by this determinant inverse or reciprocal, and you are supposed to interchange the principal diagonal elements. Off diagonal elements remain same, but their signs are changed. Okay. So since here the determinant of matrix A is 1, the A inverse is just 5 minus 7 minus 2 and 3. Okay, and if you go back in the question, this is what they are asking, no? 5 minus 7 minus 2, 3. So what they are basically asking you to find is, 1 second, yeah, see, this is nothing but A inverse. Okay, so basically they are saying that eigenvalues of A are lambda 1 and lambda 2. Then what are the eigenvalues of A inverse? So it's a standard property, right? If lambda 1 and lambda 2 are eigenvalues of matrix A, then eigenvalues of its inverse will be reciprocal of the original eigenvalues. Okay, so for any matrix, the eigenvalues of its inverse are the reciprocals of original matrix eigenvalues. Okay, that's a standard property, and that is why the correct answer should be option B. See, the thing is, if you spend this much time to observe and solve it using this technique, or this intuition, you should be fine. But if you are solving it using the conventional method, no, you have to check each and every option. In this question, you are lucky because option B was correct and you should get the answer after 2 trials. But if you are unlucky, I can give you the correct answer as the option D. And if you are doing it conventionally, you have to check all 3 options first and then 4th option. So you'll get the answer correctly, assuming that you don't commit any silly mistake, but the time will be gone. Okay, and that is sometimes the objective of the examiner. Some questions are given in your exam just to waste your time. Okay, so you are supposed to be smart about those things. Okay, it's very subjective, but with practice you'll get this confidence and you should be fine. Okay, so that is about the first question. Now let's go to the next question. So in this question, yeah, this is a question of limit, so I think calculus is coming. So you are supposed to find value of this unknown k, where the limit is limit extending to infinity x into ln of 1 minus 2 by x is equal to 1 by k. So first of all, you should know about this ln term or ln function. As x tends to infinity, this ln of 1 minus 2 by x tends to ln of 1. Okay, because 2 by x term tends to 0 and ln of 1 is 0, right? Natural log of 1 or log for any base 1, sorry, for any base log of 1 is 0. Okay, so basically in this limit, what is happening is x is tending to infinity, so this x will tend to infinity and this term will tend to 0. So this is what is basically happening here. So this is you can't solve it in a conventional way because you will not get a finite answer. So here the trick is you have to convert this into 0 by 0 form or infinity by infinity form and use the L'Hospital's rule. And the simplest way to convert this would be let's go to the next slide. You can just write limit extending to infinity, the x, take it in the denominator, that x multiplier, and let the ln term in the numerator. Okay, so if you put x equal to or x tending to infinity here, your numerator is tending to 0 because it tends to log of 1 and denominator also tends to 0. Okay, so this is nothing but 0 by 0 form, and you are supposed to solve this using L'Hospital's rule. Okay, if you don't know L'Hospital's rule, it is specifically applicable for finding the limits of 0 by 0 or infinity by infinity form, and you keep on differentiating both numerator and denominator till you get the finite answer. Okay, or differentiation is not possible anymore. So let's do that. So the limit extending to infinity remains same. Let's differentiate the numerator. So ln differentiation is 1 by argument, so it is 1 by 1 minus 2x into differentiation of 1 minus 2 by x term. Okay, so this is the chain rule of differentiation. Minus 2 comes out of the differentiation, and now you are supposed to differentiate 1 by x, so that will be minus 1 by x square. Okay, this is the complete differentiation of numerator. Denominator you only have 1 by x, that is x power minus 1, so the differentiation will be minus 1 into x power minus 2, that is nothing but minus 1 by x square. So if you look at these two terms cancel, and what is remaining here is nothing but minus 2 divided by 1 minus 2 by x. Okay, and now if you put x tending to infinity, 2 by x tends to 0, and therefore you just have minus 2 by 1. Okay, 1 minus 0 also if you want to write. So basically the limit value is minus 2. But to go back to the question, they are not asking you to find limit value. Okay, many students make this kind of mistakes also. Okay, they are not asking you to find the limit value in this question. Most of the time they do ask you, but here what they are asking you to find is k, and this k is nothing but equal to the limit value, which is minus 2. Okay, therefore k has to be minus 1 by 2. So minus half basically. And that is option C. Okay. Yeah, that is the correct answer. But again, I'm telling you, many of the students will tick option D as the correct answer because they will find the limit and just tick the answer. But sometimes examiners trick you in this type of questions. They don't ask you to find the limit value, they ask you to find something else. Okay. So be careful of these type of things. Okay. And now let's move on to the last question, where you're supposed to find the determinant of this matrix. It's a 3 by 3 matrix, and this is a data entry type of question. And you're supposed to go till the 1 decimal place accuracy. Okay. Again, this is one of those easier questions because everybody should know how to find the determinant of a 3 by 3 matrix if you are serious candidate for GATE exam. Okay. So one thing is you can do it conventionally, but I'll again give you one more additional or one more exciting way of calculating determinants. Okay. So there is a calculation of determinant by cofactor expansion. Okay. So the conventional way, what you do is also a cofactor expansion, but that you do along the first row. Nobody tells you that before. If you don't have, or if you not have heard this cofactor term, but this basically what you do conventionally is nothing but cofactor expansion along the first row. But sometimes it helps to do the cofactor expansion along first row or any row or any column where maximum zeros are there. So that trick you can use here. So there is one 0 here. So what I'll do the expansion along third column so that the life will be easy. Okay. So this expansion I'm doing along third column. Okay. So what it basically means is take each and every element of that column and multiply by the cofactor of that element. See, one element is 0 in the second row of third column. So you are supposed to multiply it by cofactor of C23. That means cofactor of element in second row and third column. Last element is 1 and it is supposed to be multiplied by C33. No need to calculate this term because it is already 0. So only you have to find two terms. And there is again this thing which is called as cofactor, writing cofactor for the particular matrix element in terms of its minor. Okay. So that is Cij is minus 1 power I plus j into Mij. Okay, where Ij is nothing but row and column index for that element. Cij is that cofactor, element cofactor, and Mij is minor. Okay, so how to find minor? Minor is nothing but determinant that you get by eliminating that row and that column from the matrix and get the determinant of rest of the terms. Okay. So therefore, this C13 will be minus 1 power 4 into M13. It is just 1 into M13, so it's basically M13. What is M13? Eliminate first row and third column, and what is remaining, take the determinant of that. So you have 2131. Okay, so that determinant is minus 1. 2 minus 3 is minus 1. Similarly, you are supposed to find C33, that will be minus 1 power 6 into M33, which is again equal to just M33. So that what M33 is meaning, eliminate third row and third column, what is remaining, take the determinant of that. So that is 1121. Okay. So that is also 1 minus 2 minus 1. Okay. So therefore, the determinant should be minus 1 into C13. So that is minus 1 into minus 1 plus 1 into C33. 1 into C33, that is also minus 1. So basically it is 1 minus 1, 0. Okay. So the correct answer is 0. Okay. Yeah, that is the answer. Okay. So you can verify this by doing your conventional method also. You'll get the same answer. Okay. So I just thought I'll give you a new way to do these things that will help you somewhere else, because instead of 1 0, if there are 2 zeros in a particular row or column, then you can use this and get the answer quickly. Okay, with less computation. Okay, so I think that is the last question. Yeah. So we'll stop here and see you next time in some other solution video.